Okay, so why did I multiply by 10? Sure. So I'll show you, what I'll try to do is I'll try to illustrate my thoughts by writing. So when I see this, I'm going to ask myself, is it ln? And the way that I really answer that question is I ask myself, is the derivative of the denominator equivalent to the numerator? So here's what I'm doing in my head. I'm doing d dx of 5x squared plus 30x. And when I do that, I'm coming up with 10x plus 30. And then I look at the numerator, and I try to match this up. And I think, maybe my first thought is, well, they don't match. But then if I take a second glance, I'm thinking to myself, wait a minute. They kind of do match because it's only a Timmy mess up. Because if I just multiplied the 10, or by the x and the 3 by a 10, then I would have 10x plus 30, right? If I distributed a 10 there. And so because multiplying the top by 10 results in a perfect chain rule for ln, then that's the only thing that works. And so then, of course, I got to multiply the SI by 1/10. So, okay.
How did you do the second part? Why didn't you multiply the two things together?
So, okay. So then the second one, hey, let me take one step back. On the second one, why was it so clear that it's not ln? What's the one symbol that messes that up? Square root. So it's not ln, so we eliminate that. So my next thought was, let's try flip up, which is what this is. So I flipped this up and got this. And then why wouldn't I multiply those together? I mean, namely, because of that.
Well, what if you put that through the whole equation?
Careful. Tread lightly, Beindorf. We might have to call the math police.
Oh, no.
So you might be thinking, why not this?
Yes.
This is, we're gonna speak very quietly so that if they have speakers and microphones, they won't hear us. Can't do that. You can't distribute an exponent. Okay. Yeah. I can prove that to you numerically if you would like.
No, it's okay.
But if you've got like a binomial, trinomial with an exponent, you cannot distribute the exponent. So then I'm basically at that point I'm stuck with the, hey, did Timmy mess this up? And I found out that similar to number one, the derivative of the inside is 10x plus 30. The other factor is x plus 3. So if I just multiplied by 10, then I'd get back to that good chain rule place. No. Can you de-earbud, please?
Yeah, sorry. Why is it times 2, not 1/2?
Good question. Okay, so if I have the antiderivative, and I'll just be a little more general here. If I have u to the negative 1/2 du, then that's clearly a power rule. So I add 1 to my old exponent, and I divide by my new exponent. Division by 1/2. Same thing as multiplying by 2.
Where did that x plus 3 go on the second part?
Yeah. So guys, I want to highlight this for you. Maybe one of you can answer this for Hunter. He's basically saying, hey, I get the whole 1/2 thing, and I get the 2 thing, but where'd the orange part go?
Back in the box.
Back in the box. So it came out as a result of a previous chain rule. We're just rewrapping all those boxes back up. So it's reintegrating back with the input. So it's disappearing back into the box.
Okay.
Yeah. So it does seem to disappear. You remember the illustration with the box? Remember how I shake the box? I'm like, you can hear it in there, right? You just can't see it. That 10x plus 30 has been back in there. We can hear it. We just can't see it. Okay. Other questions, thoughts on 1 or 2? Okay, then. So here's 3. And you can see, you almost could just tell the answer just by my highlights, right? The extra dark parts should be our intervals. So G is increasing and concave down wherever G prime is positive and decreasing at the same time. So I found those extra dark purple intervals would be what would fit those parameters, and so I came up with that -2 to -1.7. Or should be like it should be like -1.4, right? Let's make that a 4. I don't know what I was thinking. Let's go. Let's see. I'm going to make this a -1.3 or 4, something like that. And then 2 to 3.4. Yeah, I guess I can buy that. Okay. And there's, of course, the little justification on the end there, just a single sentence, single phrase. How are we doing? It's a great opportunity for you to ask a question. All right. So I have not fully checked the back end of Edpuzzle. I know that as of this morning, there was a pretty good number of you that had completed the intro activity. I'm guessing maybe some folks finished it between then and now. What did you think of area? Easier than you thought? Harder than you thought? Or just unexpected? It was all right? So, by the way, what we're about to study is the topic that has the longest history within the world as far as our class is concerned. So, a long time ago, BC actually in China is the first time that anybody has found any evidence that someone tried to find the area of some curvy object, essentially. And that's kind of what we're doing, right? We're starting to investigate that. So if y'all would flip over, and we're going to do some examples, and hopefully you're well versed enough on rectangular areas and trapezoidal areas. How many of you guys already knew the trapezoid area formula? Anybody remember that from geometry? Maybe. You had to like dig deep in to find it. It's fine. Hey, just so you know, just so y'all know, that is definitely something you need to have memorized. That's considered to be a thing you just know. Okay? So you'll get a chance to practice that today. If you would, please take a look here at number 1. Number 1 says, use a left sum and 3 equal subintervals to approximate the area between the x-axis and that parabola on the interval 1 to 7. Okay? If you want to sketch out a little graph, you're welcome to it. If you wanted to create a table, you're welcome to it. But we're using rectangles. We're using left sum rectangles, 3 of them, on this interval from 1 to 7. Okay? I gave you guys a couple minutes to try to set this up, and you may or may not get all the details worked out, or you might just be stuck, or maybe you didn't watch the video. I really wish you would. It didn't make any sense. No, all right. Is anybody else feeling that way now that there's numbers? All of a sudden, no do? Okay, here we go. It's so funny. Like the administrative types always say, you know, your students, like they don't need your direct instruction. They just need you to give them prompts just so they can like use their motivation to go learn. And I say, you know, what I see in my classroom doesn't really match up with that in the slightest. And they're like, well, yeah, no, it does. I'm like, no. You should come visit my classroom. Just saying. So let me show you. I'd be happy to show you some kind of a direct example here. I personally like this because I feel like I'm doing something. Oh, whatever. Here we go. So you guys okay with that being a parabola? 2x squared plus 5? It's been shifted where, how far?
Left 5.
All right.
Up 5. It's all good. So it's been shifted up 5, and I'm only concerned about the interval from 1 to 7, so I'm going to just try to sketch in this right half. I know it should be taller and skinnier, but I'm going to just really zoom in here just so I have a little bit of room to work. The interval is from 1 to 7. So what we are doing here is we are talking about finding the area of this awesome pink region. And this is, to me, honestly, as we go through these next couple of days, to be honest with you, this is one of the more truly amazing things about calculus. Today we're going to be approximating that area, but there will come a time when we can find exactly what that area is. It's really powerful, really cool. But if somebody tasked you to approximate this area, maybe what we're about to do would make sense. It said 3 equal subintervals. How wide would they need to be? If there was 3 equal subintervals between 1 and 7. Say again?
Wider and then skinnier.
Well, how wide?
2.
Zach keeps saying 2, and I agree. So I'd go from 1 to 3, and then I'd go from 3 to 5, and then I'd go 5 to 7. That would create 3 equal subintervals. They would all be with 2. Maybe this is the part that you'll identify with. Wouldn't a left sum use rectangles with the height based on the left edge of the interval? So I'm actually going to try to draw some awesome rectangles here. Here would be my first rectangle. Ah, so close. That make sense?
You get 258.
And then here is my next rectangle. And here's my last rectangle, like so. Ladies, gentlemen, it's making sense. I have a sense, right? I feel like there's some folks in this class that are just like, I barely have any idea what we're doing. And I feel like there are other folks that are like long since done with this question. Am I right? I feel like there's a major gap developing right now. I'm going to try to help close that gap. Maybe folks have already done this. I don't know. So here we go. I'll do my best. Are you guys all okay with the idea of me calling those left rectangles or left sum rectangles? Hopefully that goes nicely with the video. All I need to do now is find the area of said rectangles. So I'm going to say that the area is approximately, so for the blue rectangle, the base is 2, and the height, how would we figure out the height?
Use the one, just plug it.
Plug what in?
Plug 1.
1. Yeah, so if I plug 1 into the function up there, what do I get out?
7.
So that left edge has a height of 7. Talking about this, so this right here is 7. This right here is 2. So 7 by 2. I'm using the curve to find the height of the rectangle. Okay, so then for the purple rectangle, what's the base length on the purple rectangle? Well, they're all 2, aren't they? So that's not going to be a very hard one to figure out. But can you tell that the height is going to be different? How would we figure out the height for the purple rectangle?
Plug in 3.
Plug in 3. Okay, so what do we get if I do that?
23.
23. Beautiful. And finally, I come to the green rectangle. What's the base length on the green rectangle?
2.
2. And how would I figure out the height?
55.
Plug in a 5. Yep. So if I plug in a 5, what do I get out? Yeah, 55. You can tell that this curve is actually a lot steeper than how I drew it. Okay, so then you can wrap this up by doing a little addition. 14 plus 46 is 60. I got 170. You guys get the same thing? Honestly, I think I did that right, but I'm hoping I did. We all on the same page? Okay, so I want to talk to you guys a little bit about how someone would grade this. You were asked to use a left sum. I want to see this right here. Nope. I want to see this right here. That tells me that you used a left sum. So be very careful that you don't just like mentally do some quick multiplication. Show me how you did 2 times this, plus 2 times that, plus 2 times whatever. And then, of course, it's math, so we are looking for a correct answer. So this, to me, if this were a quiz question, this would clearly be a 2-point question, like maybe a test question or something like that. Be 1 point for showing evidence that you used a left sum, and then 1 point for the answer, and we're done. By the way, would my 170, would that be an underestimate or an overestimate for the true area? You can see it from the graph, right? You remember in the video how I talked about how increasing and decreasing affects accuracy? The red graph is consistently doing what? Increasing, at least on our interval, right? So we did a left sum on an increasing graph. It's got to be an underestimate. Okay. So some of you are really vocal and like, I don't know what I'm doing. I'm feeling clueless. I don't like the numbers in there, that kind of thing. Are we doing any better? Yes, no? A lot better? Fantastic.
Visual learner, that's good.
Cool. The colors even too, right?
They do help.
I like the colors. The colors make, I don't want to be like, look at that one rectangle. I want to say the green rectangle. It's easier, right? It's easier for me to keep track of too. Okay, so would you guys try number 2? Try number 2. And this one's calculator active for sure. You can clearly see there's some complicated looking stuff in there. I drew you a graph for my more visual learners. Yes, sir. Yep. Not 4 equal, but 1, 2, 3. They're not equal, like we did on that other one. Yeah. So whenever you've got data in a table, you really can only use what you're given.
Yeah, that's why I was.
Yeah. So I'll mention this to everybody here in a minute, but this format is like pretty much 100% the way you'll always see it on the AP test or the mic test. For various reasons, the intervals will be more consistent widths and that kind of thing. There are some good reasons for that. So, you bring up a fair point. I think I didn't put the word equal in there. So notice this one says use a midpoint sum. Again, hopefully that goes along with the video well. I gave you a nice table there. I gave you a graph. We can draw on the graph if we need to. We'll get this one figured out. Yeah, I think the graph and the table both really help.
That's the table down. How does it not go negative? Oh, absolutely.
Because of the absolute value?
Oh, I didn't see that.
Yeah.
Okay.
So really, I think probably if that x equals 2, there's actually a sharp point probably. Kind of hard to tell because it doesn't look that sharp, but it is almost one. I think that's right off Desmond's.
Oh, that's
I have no idea.
You guys sort of making progress, I can tell. Any questions? Okay, and you are making progress? Yes, no?
I got the table.
Got the table. Okay, that's a good start.
I wasn't able to watch the video because I was unaware it was assigned.
So Schoology, make
I
sure
know,
you
I
check
didn't
Schoology.
check Schoology, I forgot. And that
Sleep
was
is important, for sure.
It was.
Would the user then calculate out active questions or?
I'd say no. Yeah, I'd say typically those are the calculated.
I just checked this box.
Sounds like something you should see the doctor for. Guys, are you okay? I see you doing a good job drawing, everything figured out. I love the drawings, those. Hi, Isabel.
Hi.
Can I help you? Oh, so you're saying, hey, the graph should be down here.
I saw you were.
Yeah, you just have Let's see your stuff. I was looking at the wrong thing. Okay, so you got a height of 1 here. So yeah, 2 times 1 makes sense, and then 2 times 1/3. So I'd say 2 times 1 plus 2 times 1/3, assuming you take that. Good job with your picture. Okay. How do I want to do this? Let's do it this way. Here it is for number 2. I did not draw. I should probably draw on this. Like your midpoint rectangles would look like this green one and this red one would be right about there, approximately. Should maybe be a little bit taller on the red one. So then I got my table, and I got 8/3 for a final answer. Yes, good. So the first one we did a left sum. We just did a midpoint sum. We're going to get into a right sum and a trapezoid sum next. But do you have any questions before we move on? Okay, you guys are totally getting the hang of this. Just looking over shoulders, it looks really good, and you're not asking any stressful sounding questions, so I feel like you're doing okay. Here is number 3. This is the last one of these area questions for the day, and there's A, B, C, D. So, guys, can I mention a couple of brief things about this real quick? So, number 1, like Gavin had a really good point. He called me over and he said, hey, Mr. Anderson, I don't see how you can get 4 equal subintervals out of this table. And isn't he right? There's no way you're going to get 4 equal subintervals because it's 0 and 2 and 4. You're going to have to guess at the numbers in between and basically not use the table. Did you notice the first interval is 2, second one is 2, and then it's 1 and 1 for those x intervals? So they're not consistent. And let me tell you the reason for that. This is very typically how an AP test would present this, and I would do similarly to that. Here's the reasoning. They used to not do it this way. They used to do it like number 1, where they give you a function and all that stuff. And here's what happened. Some smart student figured out how to program into their calculator a way for the following things to happen. You input the function, you input the interval and the number of subintervals and left sum, right sum, midpoint sum. You tell the calculator what you want it to do. And then what this program would do is it would spit out a graph of the function with the rectangles drawn in, with all the steps with the left sum, right sum, midpoint sum, whatever it was, written out on the calculator screen for you, and the answer. Amazing, right? So Joe, let's talk about that. Wouldn't you all agree with me that whoever it was, or the whoever's it was that wrote that, they probably really understand left sum, right sum, midpoint sum? Like, somebody just said they should get extra credit for that. I'm like, well, maybe they should, because that's really impressive. Great job, you know? But you know what happened, though, don't you? They gave it away. They sold it. They whatevered it. They shared it with people. And now people that had no idea what they're doing looked like they definitely knew what they were doing. And the powers that be were not okay with that. As you should not be okay with that either, especially if you're the one that actually knows what you're doing. You shouldn't be okay with that. So in any case, they said, you know what, we have a way around this, and this is it. So it's unpredictable. There's no way a program could be written for this. Yet you can still show that you know what a left sum, right sum, midpoint sum, trapezoid sum, whatever it is, happens to be. So you guys would please try ABCD. Show you some answers in a few minutes. And I think as long as we're fairly efficient here, we should be able to go on to one more challenging antiderivative question. If you look back here in the back board, somebody came in today at lunch, a couple of somebody's came in at lunch, and we worked on some of those challenging antiderivatives. They're fairly easy to make up for the most part. And so if tomorrow, if you said, you know what, maybe I should come in at lunch and we can work on that, we can do that. So come on, okay? So we'll try to get at least one more of those in today. We even did a completing the square today at lunch. What? Yeah, I like that one too. I think, we skipped around. We totally skipped around.
How are we supposed to do this?
The in-between stuff? No, definitely not. So like with this one here, you would run the sum, and 2 7 intervals go 0 to 4, so your 7 intervals would be 0 to 2. Okay. But you had asked a really good question. I think it's good for the group. You guys listen up. If you are given a table like number 3 and you find yourself trying to estimate what's happening like in between, you with me? Like if you're guessing, okay, I see that there's a 0 to 2 interval, but I feel compelled to figure out what if x was 1, would y be 10 or 9 or something like that? If you feel yourself doing that, stop. You will never ever need to do that. Only use the data explicitly from the table. Never take a guess as what's going on in between. Okay? As long as the question is well written, then like the numbers of subintervals and all that stuff should go along nicely with that. So do as much of this as you can. I'll get some answers up there in a little bit. I know sometimes when you have a table like this, sometimes it's nice to do a rough sketch of the graph, kind of like we did with number 1 and like we saw with number 2. There's no requirement that you do that, but it's certainly not wrong if you do. Discussing, let me know if you have any questions. Where are you getting this 1 from?
Yeah.
Don't you use the table data? Shoot, 0 to 2 is 1 subinterval, 2 to 4 is your second. Nope, just 4 subintervals. And that's actually exactly the point that Gavin brought up. It's like, hey, wait, if you equal ones, unless they're 1.5, like you said,
And it doesn't matter.
they could be different. And sometimes that's actually an advantage graphically to do it that way. I don't know if it is here. Sometimes it is. Wait, what?
You can not have
So-
any be equal?
Yeah, so notice I didn't say 4 equal subintervals, I just said 4 subintervals. And since you can only use the data from the table, your first subinterval would be from 0 to 2.
Yeah.
Second one would be from 2 to 4. Third is from 4 to 5. Fourth is from 5 to 6.
2 to 2, 2 to 4,
Yep.
4 to 5.
And 5 to 6. Yep. So basically you have wide, wide, skinny, skinny.
Okay.
Are you doing that triple one? Hey, if you guys happen to get done with this and you want to be productive, which I hope that you do, number 3 from yesterday, so if you go back in time to number 3, I think that's a worthy effort for you with those antiderivatives.
18 plus 12 is 30 plus
What else? I say something else really important. So that means 34.
Oh, which one else?
Yeah, well, rest on it. Does that help?
2 times 6, 12. 4 times 2.
Did you get 14 increasing and you use the left sum?
3 times 2.
So what you'd want to write there is you'd want to connect those two concepts and say, over because we use a left sum on your decreasing. Use a midpoint. Yeah. So it says midpoint at 2 subintervals, right? So instead of 4 like the other ones, it's only 2. So what do you think? Do you see any intervals up there that have intervals?
Or negative 14.
Yes. Oh, wait. In fact, I would say more often than not, at least in AT stuff, the intervals will be 9. Yeah, that's where you get tempted to be like, oh, we have to do these two. I think on RoboSign Live, we'll find out all these variables, because it's very much like a college way of doing things. It's also the midpoint, you start in the middle. Hey, again, if you happen to get done with this, I'm going to show you some answers here in a couple minutes. You could try number 3 from yesterday. That would be a good review question. And I think probably what I'll do is I'll make videos for the ones that we didn't get to those last couple of days. Keep working on number 3 up there. In fact, for those that are done, maybe I'll get the answers up there just for those that are all the way done. So A, I got 38. And I said it was an overestimate because we used the left sum on a decreasing graph. B, that don't make sense. 1 times 12 and 1 times 2, 6 plus 6 is 12. Oh, wait a minute. That's 12, yeah, 12 plus 6 is 18, 30, 32. I guess 32 makes sense on B. C, you can see it, all my trapezoids there. Remember with all these, if you're using a left sum, right sum, midpoint sum, trapezoid sum, I need to see those lines where I'm seeing the multiplication, right? Where there's evidence that you actually did use trapezoids, or you did use a left sum or whatever. So I think you're seeing all that there. And then D, of course, is a midpoint sum, 4 times 6, 2 times 12, sure, 48. Makes sense there.
Why is it 4 times 6 and 2 times 12?
So yeah, so I'm using 2 subintervals and a midpoint sum. So I'll just go back up to the table for this. So my 2 subintervals would be here and here. So when I go from 0 to 4, my base is 4.
Okay.
And then the height at the midpoint
Oh.
is 6.
Okay.
And then you can see over here, if I go from 4 to 6, my base length is 2, and the height at the midpoint is 12.
Okay.
Boy, if somebody looked at that, they'd wonder what in the world that was, but I think you figured
I
it
got
out.
it.
All right. Well, why don't I show you, I'll show you a quick answer for that number 3 from yesterday, and then that'll be good for today. So number 3, there's all those. There's number 3. So for number 3, the first one was an arctan. Second one was a natural log. And the third one was a flip up. So there was actually 3 of the 4 possibilities right there in
How did you get
one
the,
question.
Why did you multiply it times 15?
15.
Yeah.
So I went through my steps and I got to arctan.
Mm-hmm.
So for arctan, the numerator has to be u prime times a. And I know that my u prime was 3.
Oh, yeah.
And my a was 5.
Okay.
So 3 times 5 being 15. That's where that came from. Yeah. Hey, you guys are all good to go. Hope you have a wonderful day and weekend. See you on Monday, or if you want to come to lunch tomorrow, we can do stuff like that. A little more practice is never going to hurt. I'll probably push out a video with some of these on there for you, the ones we didn't get to. Hope you have a wonderful day. See you guys.